Yes, welcome. Today we are going to be learning units. Today we are going to be learning what? Units in physics. Units in physics. Every quantity in physics has a unit. Every quantity in physics has a what? Unit. You use unit to identify the kind or the type of quantity in question. You use the unit to identify the kind or type of quantity in what? Question. When we talk about time, the unit for time is seconds. The unit for time is what? Seconds. The unit for time is what?
Seconds.
S. So when you say that he came here or he traveled from A to B within the time of 30 minutes, within the time of what? 30 what? Minutes or 30 what? Seconds. You understand? That seconds is the unit. You use it to identify it. Whenever you see here 30 minutes, then you're talking about what? Time. When you say he walked a distance of 200 kilometers. 200 what? Kilometers. The unit there is what? Kilometer. The unit there is what? Kilometers. 200 kilometers. Whenever you hear 200 kilometers, you know you're talking about what? Distance. You know you're talking about what? Distance. So the unit tells you the quantity in question. If the unit is seconds, what quantity are you discussing about? Time. If the unit is meters, what quantity are you talking about? Distance. If the unit is gram or kilogram, what quantity are you talking about? What quantity if the unit is kilogram? Mass. Is that clear? When the unit is meter per second, what quantity are you talking about? Velocity or speed? You understand? Every quantity has its unit. Every quantity has its what? Units. So today we are going to be learning the systems of units. In physics, there are about 4 systems of units. In physics, there are about how many systems of units? 4. You understand? So depending on where you're working or the country where you are, you can be using either of these systems of units. Is that clear? There are some units that you see people that are in the architectural field, they use it. Engineers, they use their own. You understand? But these are the basic 4. These are the 4 systems of units that we have. We have what we call meter, kilogram, second. Meter is for which quantity? Length. Kilogram is for which quantity? Mass. Second is for which quantity? Time. You understand? And you know we say that the basic quantities are length, mass and what? Time. LMT. Is it not? That was what we did when we are still in dimensions. So one major system of units is the meter, kilogram, second. In short from MKS. Where M is what? Meter, K is kilogram, S is what? Second. Another system of units is the Gaussian system that has centimeter, gram, second. Centimeter, gram, what? Second. CGS. That's another system of units. Then we have another system of known as the British engineering unit that uses foot-pound system. That uses what? Foot-pound system. That's another system of units. And finally, we have the generally accepted unit, which is the unit that science uses. The generally what? Accepted unit, which is the unit that is used all over the world by science, known as the what? SI what? Unit. SI what? Unit. SI unit. This SI stands for System International. You understand? System International. System International. SI. System International, the unit. SI unit. That's the full meaning of SI unit. System International, the unit. That is the generally accepted word. System of units that is used everywhere in the world. You understand? So you can use either of these system units. You can use meter, kilogram, second, MKS. You can use the Gaussian. You can use the British engineering unit of foot-pound system. You can also use the SI unit. But the one that everybody is using is the what? SI unit. That is generally SI. If you go to France, you go to the United States of America, you go to Britain, everybody try to use the system international the unit. In that way you understand every quantity because the systems are uniform everywhere in the world. You understand? The British engineering unit is majorly used in Britain. You understand? But what if you go to America or you go to France? Will they be able to understand what the unit is? That's why we have this general unit. System, international the unit. Every country understands it, and that's what we are using. Is that clear? Types of units of measurement. Types of units of measurement. We have two types of units. We have the fundamental unit and the what? Derived unit. We have the fundamental unit and the what? Derived unit. Those are the two types of units. And fundamental units are units from which other units can be obtained. Units from which other units can be what? Obtained. And those units are M, standing for what? Meter, isn't it? Then S, standing for what? Seconds. And what? What was the last one? Huh? M. L. No. No. The three basic quantities are length, time and what? Length, time and what? Length, time and mass. Those are the three. So for length is meter, for time is seconds, then for mass is what? Kg. Kilogram. Is that clear? So these three are the three basic units: meter, seconds, and what? Kilogram. Then we are going to be learning the derived units, how they are derived. Is this clear? Good. So we say we have fundamental what? Fundamental what? Units. Then we have what? Derived what? Units. Fundamental and derived units. Those are the two units that we have in physics. In physics, the two units we have are the fundamental and the what? Derived units. Fundamental and derived units. So here we have the quantity to be measured. Then here we have the measurement units. Measurement units. That's the units that it is measured in. Measurement unit. And here we have the what? Symbol. Here we have the symbol. Have the symbol. So earlier we learned about the fundamental quantities. What are the fundamental quantities? Give me an example of the fundamental quantities. The quantity, not the unit. What are the fundamental quantities? Take your notes and see the different kinds of quantities. Fundamental quantities are time. Which other one? Which other fundamental? Mass. Which other fundamental quantity? Length. Which other fundamental quantity? Which other fundamental quantity? Luminous what? luminous intensity. You also have temperature, isn't it? Temperature, luminous intensity, electric current, isn't it? Now, these are the fundamental quantities. And I told you that every quantity has a unit. So what is the unit for time? What's the unit for time? Seconds. Huh? Unit for time is seconds. What's that of mass? Kilogram. Huh? Kilogram. That's the unit for mass. What of length? Meter. Huh? What of luminous intensity? Temperature and current. What of luminous intensity? Luminous intensity is candela. Is what? Candela. Luminous intensity is what? Candela. Is what? Candela. What of temperature? Kelvin. Temperature is what? Kelvin. What of electric current? Ampere. Electric current is what? Electric current is what? Ampere. So what's the symbol for seconds? S. What's the symbol for kilogram? What's the symbol for meter? What's the symbol for candela? CD. What's the symbol for Kelvin? What's the symbol for ampere? So those are the symbols. So these symbols are normally what we use in mathematical representations. You understand? If you want to say a time of 10 what? Seconds. This is time, is it not? This is what? Time. Time of what? 10 seconds. Showing us the magnitude of the time and the units. The unit is in seconds. Is that clear? So this is what we are learning. The unit. This second part. The units. You know, we also have one other fundamental quantity. What's the name of that fundamental quantity? One remaining fundamental quantity. Temperature, we've already mentioned that. Amount of substance, that's the last one. Amount of substance. And what's the measurement unit? Mole. Represented as what? M. Is that clear? Is that clear? Is that clear? So represented as mole. Now, what are the derived units? The units that can be gotten from the fundamental units. Number one here is what? Force. Do you know we have force? Force is a derived unit. What other example of derived unit do we have? Acceleration. Yeah, acceleration, work, density, acceleration. Exactly. Power, momentum. Power what? Momentum. Then we also have electric charge. We also have what? Electric charge. Who can tell me the SI unit for force? What's the SI unit for force? The SI unit for force is Newton. Is that clear? The SI unit for force is Newton. What's the SI unit for work? Joules. Good. Joules. Very, very important. It comes out in JAM from time to time. Make sure you learn them. Joules. What's the SI unit for density? Density is, the SI unit is kilogram per meter cube. Kilogram per meter cube. The SI unit for density is kilogram per meter cube. Kilogram per meter was cube. What's the SI unit for acceleration? Meter per second square. Meter per second what? Square. What's the SI unit for power? The SI unit for power is watts. Is what? Watts. What's the SI unit for momentum? Momentum is Newton second. Newton second. What's the SI unit for electric charge? What's the SI unit for electric charge? Coulomb. The SI unit for electric charge is what? Coulomb. So the SI unit for force is Newton, represented as N. Represented as what? N. The SI unit for work is joules, represented by J. The SI unit for density is kilogram per meter cube, represented by kg per meter cube. Is that clear? What's the SI unit for acceleration? Meter per second square. M per second square. What's the SI unit for power? Watts. What's the SI unit for momentum? Newton seconds. What's the SI unit for electric charge? Coulomb. Is that clear? So those are the units. Those are the units. These are the fundamental units. These are the what? Fundamental units. And we said that fundamental units are those units from which other units are gotten. So from the fundamental units you can get the derived what? Units. So the fundamental units are the units for quantities like time, mass, length, luminous intensity, temperature, electric current, and amount of substance. And their various units are: for time we have seconds, for mass we have kilogram, for length we have meter, for luminous density we have candela, for temperature we have Kelvin, for electric current we have ampere, for amount of substance we have mole, and those are their symbols. For the derived units, the unit of force is Newton. The unit for work is joules. The unit for density is kilogram per meter cubed. The unit for acceleration is meter per second squared. The unit for power is watt. The unit for momentum is Newton second. The unit for electric charge is coulomb. Is that clear? So those are the units in physics. Those are the units in physics. Very important. They are very, very important whenever you represent a quantity. The way you represent a quantity in physics is that you write the magnitude of the quantity attached to the what? Unit. The magnitude of the quantity attached to the what? Unit. The quantity being represented by 10 seconds is what? Time. The quantity is what? Time. The unit of time is what? Seconds. And the magnitude of this quantity is 10. Is that clear? Is that clear? When you say 200 kilometer, what quantity are you representing? 200 kilometer, what quantity? What physics quantity?
Mass.
200 kilometer, what quantity? Kilometer. 200 kilometer, what is kilometer representing? Length. 200 kilometer is representing what? Length. And the magnitude is what? 200, whereas the unit is what? Kilometer. You understand? Meter and kilometer are similar, except that one is the multiple of the other one. One is the multiple of what? The other one. So finish copying so that I can show the relationship between kilometer and meter. When you have 1,000 meter is equal to 1 kilometer. 1,000 meter is equal to what? 1 kilometer. So both of them are representing length, but in different ways.